So, good evening to everyone. We are Team Haribo, and we are glad to be here to present you our results and findings in our final project in Introduction to Data Science course, which was devoted to applying data science to help the data science and self-learning process. And our team consists of 4 members. They are Alexander Onbish, Ilya Kachko, Emanuel Tipo, and me, Dmitry Lichowitsky. And we've split our efforts to analyze 3 independent data sources. The first was job postings from Indeed.com and Glassdoor.com, worldwide, not restricted to any country. The second was community opinion based from Kaggle Data Service conducted in 2018 and 2019. And the third one was parsing some data science skills from Coursera courses that are related to data science. And in our course, in our project, we had 2 objectives. The first one is to design an introduction to data science course, which we did based on the skills that are taught in courses from top universities on data science on Coursera, and also on the most frequent skills in data science job postings. And the second objective was to design a Master of Data Science program, which we did based on more in-depth analysis on skills frequency of their occurrence and co-occurrence in job postings, and also on the current community opinion on what is trendy, hot, and so on in data science based on Kaggle survey. The first thing we've analyzed, this job was mainly done by Alexander, is parsing Coursera data science skills. So we found some nice tools on doing web scraping, and we found keywords that were listed in Coursera data science courses, and built some dependence analysis of these keywords. So this is actually frequency of occurrence of keywords was frequent in separate courses, and then we did some hierarchical clustering and applied it to most frequent skills listed in courses, merit test courses for beginners, and then for general pool of data science courses, and had some supported our ideas into how the courses in data science, how the skills in data science should be divided by different courses, skills groups. Next, we've proceeded and did some analysis of job postings from Indeed.com and Glassdoor. The idea was the same. We scraped job descriptions for all the titles that are somewhat related to data science. That is, data scientist itself, machine learning engineer, AI engineer, business analyst, data analyst, and selected a list of skills, already grouped them that might be related to data science, and counted how frequently they appear in different job postings. So the chart on the left shows you what are the most frequent skills listed in job postings. So of no surprise, these are machine learning and Python, but which is somewhat that should be taken into attention is that communication also is in top 3 skills, which means that really soft skills matter. So also there are Excel, funny, artificial neural networks, algorithms, and so on. The chart on the right shows how the relative frequency of different skills group, which might be very useful when we want to split credits between different courses in our master's program. So we clearly see there are 5 major groups, which are general data science skills like data analytics, data extraction, basic machine learning, and so on. Soft skills, top 2 group, programming, which will be the basis of most of our courses. So no separate courses for it, but included everywhere. Deep learning, the hottest topic in machine learning nowadays, and statistical software for some fast statistical analysis of data. Math, computing, and big data are also 3 large groups, which is a bit surprising. Extracurricular activities are not very required in demands of job employers. So they usually do not want you that much to have these skills. Although top-tier companies that do some advanced research like DeepMind, Facebook AI, and so on, they usually prefer the candidates who do extracurricular activities. So it's up to the candidate, up to the student itself to select whether he wants to do it. But if he wants or she, the university probably gotta support it. And also, we've built some skills graph of the skills that appear in job postings. There are top 20 skills, and we've connected the skills with a simple line. If the skills are complementary, that is appear in postings together frequently, and with dashed lines if they are mutually exclusive, that is, they usually do not appear in the same job posting. And we've plotted it as a graph that is laid out in the way that we can clearly see some clusters of the skills, like Python, Scala, machine learning, algorithms, deep learning, they stay together. There is a separate cluster devoted to data interpretation and delivery. Also, the part that is related to data analysis and engineering, and a separate cluster, just leadership, like a soft skill. Next, when we've analyzed what the skill demand side of the skills market wants to have, next we proceed to the supply side, to like the people who supply the skills to the data science community. So we've did analysis of two last Kaggle data surveys to explore what are the most trendy things, trendy programming languages, trendy frameworks, and so on. And we've presented here, of no surprise, most common skills like, again, are Python, machine learning, data science, and we've analyzed 3 different data sets, relatively independent, and we found these skills appearing in the top of all the data sets. So we've decided that this should be the core of our introduction to data science program. So these skills can be taught in one course, and as they are the most important, they probably should be taught in the beginning. Also, we've plotted the job distribution by job. So we've collected all the jobs that are, all the vacancies that are somewhat related to data science. So the first probably 5 are more related, the next are like near to the data science, and we can analyze the most desired, most payable positions. And these are research scientist, software engineer, so of no surprise, coding is important and rewarding in data science, and probably some vacancies like chief data officer that became arising. Well, after we've analyzed all the data, we've created our first introduction to data science course and then master program. So our based on our analytics, we suggest making the intro to this course as a combination of 6 modules. The first one, probably the most important, is a general description of what data science is, of like what problem it solves with which methods, and basically in some sense it's what we had in our first lecture. Although in our opinion, introduction to data science course should covers a bit more detail, a bit more topics, like the classical data science process of data analytics, data visualization, data modeling, and importantly, data extraction and cleaning, which is a major part of doing data science job. And as we've seen that Python is most popular language for doing data science, we suggest accompanying every of these skills, every of these models with corresponding Python package. So like for analytics, it's Pandas, for modeling is scikit-learn, and so on. And the project should be finalized with, a course should be finalized with a group project, like we have now, which allows students to develop communication skills, visualization, presentation skills. Also, it gathers together all the previous modules that were studied by them and simply add the project to a student's portfolio. Next, we've used our analysis to design a Master of Science in Data Science program. So we have made a few course selection decisions. So importantly, we allocate credits partially based on the demand on the skills groups, which was presented before, and also on our common sense, understanding of how the data science program should look, on the programs in data science from the top universities like Harvard, Carnegie Mellon, Twente, and so on. And finally, we make a decision that we should focus on the data science itself, programming, mathematics, and soft skills. And also we suggest to make a rich selection of courses on machine learning applications, not only classical computer vision or NLP, but also machine learning in healthcare, in bioinformatics, in quantitative finance, so that the students could push the boundaries of machine learning and put it into the new context, new industries. So here's a few words on our program structure, but it's simpler to see it visually. So the program is 4 terms, 30 credits each, and we've made a non-standard decision probably for Ukraine to make a few courses, like 12 only, but make these courses very large so that they cover all the topics, and simultaneously students would not spread on too many topics simultaneously. So the first 2 semester terms, they give you 1 course on math, 1 course on data science. So the first is intro data science, the second term is intro to machine learning, 4 courses on soft skills, like 4 half semester courses, because we've seen how important they are, and also 2 menu courses. Menu is like obligatory to select from one of the group. So menu 1 is obligatory computing course, cloud computing, high performance, advanced algorithms, and menu 2 is a course on hot topics in machine learning. So either deep learning, reinforcement learning, or probabilistic graphical models. 3 hot topics in ML research today. The third term is completely at students' discretionary, so they at first can select whether to take a course-based option, which allows to take 4 electives, or research-based, which is 2 electives and large research project. And electives probably should be everything that students or teachers can imagine. So we suggest computer vision, NLP, advanced ML, bioinformatics, quant finance, but this is not the whole list. And the fourth term is for thesis. Well, that's all for our project. So we've also made tech startups that address some of the issues that we've encountered during our analysis. So to say it short, these are Open Course by Ilya, which is an open source computer science platform for open courses, supported by the community, not some universities or institutions. Second is Paper Hub by Alex, which is a powerful manager of all the papers you read, because nowadays we have too much sources of different scientific papers, industry papers, Medium, arXiv, so much of everything, and it will be useful to have a single application that allows you to manage it all. And the last one is FileLearnX, which is a knowledge platform that allows you to, by answering, which simply gives you an answer to this simple question, like why learn math? Why learn math as data science? Why learn music theory if I just want to play guitar? And so on. And basically this solves a pretty major problem in Ukrainian education, because students don't immediately see how to apply the skill they learn, and thus struggle to learn the skill thereafter. So this application would just simply remove this gap and allow them to learn more efficiently. So that's all from us. Thank you. Thanks.
Okay, thank you. A couple of questions from my side. So first, interesting observation that you stressed, unlike the other groups, you stressed applied courses. And you mentioned mostly 2 topics, finance and bioinformatics, if I remember correctly. So yeah, so which applications you find are most useful, and which applied courses you propose to include in the program, and why?
Okay, healthcare and biology, bioinformatics, because these industries really need some machine learning. Probably astronomics, because there is too much data about the space that should be analyzed, and in this industry there's not so much specialists in data, so this could be of much use. Also finance, because in our days of trading robots, it's pretty cool to create a smart trading robot that would do this based on machine learning. Probably, yeah, do you have anything to add?
And any analytics support in why these application areas should be included? So why for instance, healthcare and finance should be included, but why marketing should be excluded as an application area?
Actually, it was not so simple to find very major, how to say, these application areas were not didn't have this much quantities in job postings. So there is a lot of applications, but not a single application that has so much jobs in it. So this is like where the data should be augmented with our reasoning. So data doesn't show us that in any particular area of applications there is very much demand, a large demand for this. But we understand that it's not jobs don't show us all the truth in this case.
But how about, so in the Kaggle data set, you have the industry in which person works. So that's this data, and you have the salary. So how about this dependence of the salary on the industry that you work? Any insights from that, or you didn't look at that?
Personally, I didn't do it, but I think that machine learning guys who work in finance probably earn very much more than others, although there might be some other cases interesting.
Okay, second question is about, so you proposed course-based versus research-based options in the program. So how do you propose to structure those, the course-based master program versus research-based master program? So what are the differences?
The differences come in the third term, so basically the number of electives. So you either take 30 credits of elective courses, or you take 15 credits of courses, and 15 credits to either do internship or do research, or like to take more time for your thesis and so on. So basically 15 credits either in electives or in research.
So what type of research?
An
example.
You have to propose some thesis.
What thesis you have? Thesis for the post semester. What's the difference?
Extended research. Like
examples. Make an example.
You don't. You understand that you don't have time to build a complete like system to play poker using artificial intelligence in 30 credits. So you decide to take 2 months more to build it, or you want to join some company as an intern to gain some practical knowledge in some industry, like in bioinformatics. You have to work with professors or
so internship is obvious example, but we're talking not about internship but about research. And when you say that, oh, I need another 15 credits, so how you prove it for the like head of the program, the dean, for instance? So you're not the lazy student from the second team.
Of course, you have a final presentation after the research project, and the deadlines, and the project is curated, so you're not left alone to spend these 15 credits as you wish. You're curated. Probably students may be joined into some groups, and there are some checkpoints, like in the middle of term and.
Sander?
Yeah, and the last question from my side. So you propose this graphical models course. So what do you propose to include in this course? Graph models, network models, and or anything else? And yeah, the design of this course.
It's actually the course about Bayesian and Markov nets. So you represent like random variables as graphs. And this allows you to simplify a lot of computation when you do some probabilistic inference. And this is kind of the topics that is worked on in Stanford, and is quite promising. So it's not about networks like social networks. It's more like a convenient way to represent randomness in our data. Convenient and computationally more efficient way to represent data. So Bayesian networks, Markov networks, then inference in these models, and learning of probabilistic models.
And what are the applications for these algorithms?
Applications are mostly in physics and in healthcare and biology also. So these 3 topics that are of the largest use. These are the applications that Stanford to develop their efforts to, but probably one can invent some other ideas, like using it in build an expert system of our century.
Yeah, thank you.
Yes, I have two small questions. So what about, so should we include Excel in our program?
It's an interesting question because whatever you do, Excel is always an important part because you sometimes don't have time to learn some Python framework and you just want to take a look at data. But I guess it's not, it shouldn't be learned intentionally, but leave it to students and they'll use it when they need it. And they'll hope someday it will live and won't appear so surprisingly in this.
It's more provocative question. But when about this graph you mentioned, I'm not sure. So probably you draw the graph before taking course on data visualization.
This one?
Yeah, this one, because it's impossible to understand what's going on there.
Yeah, it's kind of hard to build a graph without intersections.
Yeah, so my question here, so between deep learning and machine learning, is it solid line or dash line?
It's solid line.
Solid line. So it means that it's there.
No. Solid line means that they are co-occurring in the same geometries. And dash means that they are exclusive.
Okay, thank you so much. No questions. Thank you, guys.